Okay, good morning. Welcome to
KidMath146.
KidMath number 146. Now, you're still getting back from being sick, so we're still kind of taking it easy, and we're just talking about some fun stuff with logs. So remember, we talked about this yesterday, e to the pi plus 1 equals 0? Do you?
Yeah.
Okay. And so that just meant e to the pi I is minus 1. And there was one thing I was thinking of this morning, when I saw it written up on the board when we came in to do the normal stuff we did today. I thought, oh, you know what would be fun is I'm gonna calculate I to the I for you. I to the I-th power. Like, what does that even mean? You know?
Well, that's like the square root of minus 1 to the square root of minus 1.
Yeah, so because we've been doing these problems with logs and we had weird powers, right? Like we had today in one of the example problems we had 3 to the square root of 3 to like the minus 4/3 or something. You know, whatever it was. I don't remember exactly. But I to the I. Can you see something that we could do to both sides of this equation to produce an I?
Well, we could square both. We could take the square root of both sides.
Yeah, let's take the square root of both sides. Okay. So this is e to the pi I to the 1/2 power. And this is the square root of minus 1.
I.
Which is just I. Okay. And what happens to the powers here?
They multiply.
Okay, so what is e to the pi I to the 1/2 power
It's
equal?
e to the pi I over 2.
Very good. E to the pi I over 2 equals I. Actually, let me make my e a little bit bigger so you can see the power. E to the pi I over 2 equals I. Now I want to produce I to the I. So what do I need to do to both sides?
We have to raise everything to the I-th power.
To raise everything to the I-th power. Okay. I also need a working marker. The I-th power to the I-th power. Okay. So on this side I have I to the I, which is exactly what I was hoping for. What do I have on this side?
Well, you've got e to the pi I squared, because you've the multiplying i's. You've
Right.
e to the minus pi over 2.
E to the minus pi over 2. Now, what's surprising about this number?
That doesn't have any i's in it.
It doesn't have any i's in it.
But this can kind of be simplified a little further.
Can it? How? What do you want to do?
Well, can't the negative flip it over?
Oh, yeah, that's true. Okay, so you could, if you wanted to, write this as 1 over e to the pi over 2. But that's not simplified or any really different. So we just have this amazing fact. And it relies on one thing. Remember I told you this thing yesterday, I told you these things with i's and the logs and exponentials are a little more complicated than I'm letting on.
Yeah.
It relies on a couple things that our power rules remain true with i's. Okay, so we gotta we've never checked that that's true, by the way. And remember I told you yesterday this weird equation, this marker, time to buy some new markers, e to the pi I equals minus 1. When we cube both sides, we get e to the, where's the other marker?
This one, I think.
When I cube this side, I get e to the 3 pi I also equals negative 1, because negative 1 cubed is negative 1, and this cubed is just multiplying the power by 3. So something strange is happening here, because these are two different numbers that e to the two different numbers produces the same thing. So something else weird behind the scenes, but I don't want to focus on that too much, especially since my markers aren't working. But looks like we found that I to the I is equal to e to the minus pi over 2. So there's another relationship between e and pi and I, besides just this equation. E to the minus pi over 2 is I to the I. I to the I seems to be a real number. Pretty cool, right? Right?
Yeah.
All right, good job this morning, then.